Hello everyone and welcome back to Adrian's Digital Basement 2. This is an XT motherboard here, and I worked on this on another second channel video. I have a note here that says error 4 XT, like a RAM question mark problem. I think this board was from a Laser 128 XT clone, and this board is just a blatant XT clone. Like it's total copy of the IBM motherboard, although I'm sure it had Phoenix BIOS chips or whatever, which is why it was able to be sold. Anyways, I don't think this thing ever quite worked properly, and I thought after just working on a repair video on an actual 5160 motherboard, I have the diagnostic ROM that I used to work on that. I figured I could just put it in here, see what happens. Maybe this thing is compatible. And I'm actually noticing there's one RAM chip that's been pillaged, so I stole that. But anyways, I'll pop this in, I'll put the RAM chip back in there, and then I guess we'll find out if this diagnostic ROM actually can work on these clone machines. So let's pop out the PC Turbo BIOS chip here. This would almost certainly be a 32K one. This obviously has provisions to use smaller capacity EPROMs, and probably you can install the IBM basic BIOS on this thing as well, which on the IBM it had one 32K EPROM and then one 8K EPROM to make up the full set. Although now that I look at it, this says that this is a 2764, and it does say here that it supports 64K or 128K EPROMs. So how funny that the BIOS is so small. This is an 8K ROM versus the 32K one that was on the IBM. So this board is 640K. These are MT RAM chips, but they are 256 each bank, and then these are 64K. I've gone ahead and grabbed 150 nanosecond 64K RAM chip to populate the stolen one. Looking at these other ICs, these Hitachi branded ICs, I think I stole the RAM chip and stuck it on the other XT motherboard, the 5160. All right, over to the RGB to HDMI. Where's the power switch? Here it is. Let's turn that on. All right, well, the ROM is running, so that's a good sign. Ignore the fringing. That's just the syncing of the CGA card and the RGB to HDMI not being perfect. I just have to go into the RGB to HDMI to tweak that, to fix that up. You can find the ROM at the link in the description. I got it from -0 degrees. It's the one for the 5160. It's doing a RAM check right now. It passed with no errors. So maybe whatever's wrong with this motherboard is something else. So that was system memory to A000000, and it is doing a slow refresh right now. So I think that's like a more thorough RAM test. And if there is any RAM problems, we should see it down here in this part of the screen. I'm pretty sure this diagnostic ROM is only 8K in size, which means that it is the same exact size as this EPROM right here, which is a 64 kilobit EPROM, kilobit, so 8 kilobytes, which is why it would just work perfectly when I stuck it onto this motherboard. So I think this might be useful information to anyone who's trying to troubleshoot your Laser XT Turbo motherboard, which I'm pretty sure that's what this is. You can use the super soft ROM diagnostic and just stick that into that first socket and it will work. If I were going to try to replace the BIOS on here with, say, the IBM one or some other BIOS, I'm going to have to split that up into little 8K chunks and then flash a bunch of these 2764 chips. So far, so good on the RAM check. It's up to address 40,000 on the slow memory refresh test. So I'm really wondering if that error is something else. Incidentally, this CGA card here is a clone CGA card, and it has a wider slot bracket on it, which means it was most likely designed for use on the original IBM 5150, because it had only 5 slots as opposed to 8 like the XT, so the slot brackets are wider. The memory test is plodding along, but I think it's gonna work, which is weird. The memory test is good. Okay, let me unplug the speaker, that's annoying. The error is the BIOS, and that's of course expected because I don't have the original IBM BIOS in there, and that's what this is looking for. So all of these are gonna fail. But every other test worked. So what exactly is causing this stupid error 4? Well, I mean, I think that error 4 is happening. I should put that original ROM back in, and we'll see. I know it's not easy to see, but the original ROM is back in. There it is right there. PC Turbo 98, or 89, sorry. All right, power on. Don't really remember this looking like this, but color graphics, RAM testing. Well, I'm not getting the error 4 anymore, but it just sort of hangs here at the boot screen. Let's see if I can Control Delete. All right, so that is actually rebooting. But it's funny, it starts to access the floppy right here, way on the edge of your screen, but it doesn't boot. Well, I suppose at this point, it could possibly be the dip switches that are on here. I don't know how those are configured. Dip switches are right here. All right, I've looked up dip switch settings for the Turbo XT, and I'm pretty sure it's the same motherboard. Looks like it has a copy exactly of the IBM dip switch settings. So one should be off. Math coprocessor should be on. That's switch 2, it is. Maximum amount of memory installed is off, off. If that's correct, off, off. Color display, 80 columns should be on, off. That's 5 and 6. On, off is correct, correct. And then floppy drives, one floppy drive, which is all I actually have, 7 and 8 should be both on. Okay, so it's currently set for 2 drives. Now it's set for 1 drive. Maybe that was keeping it from booting. I'm looking at the chips on the main board as this boots, and no booting still. Come on. Anyways, it looks like it's from 1986, this machine. Let me try the XT IDE here, see if this thing can boot it. Will it work, or will it still not work? With that card in there, getting no display at all. Let's make sure nothing popped out of this thing. Oh, no, I plugged that in backwards. No, I hope I didn't wreck my XT IDE card. Oh, look at me, I'm so bad with this backwards thing. All right, here we go. At least it's all socketed, so if I did damage something, I can fix it. Error 20. Oh no. Let's pop this out. Did I wreck this card? Let's see. Okay, no, it's still working at least. All right, the computer tried to boot off here just as it did before and didn't work. So I'm always used to working on these motherboards the other way, turned around 180 degrees. And yeah, I probably killed this card. As I said, everything's in sockets. It's all jelly bean parts, so it's not the end of the world. Back to trying floppies again, and it's weird. It's just not booting off this one. Although if I take the disk out and I reboot, it does say insert a disk in drive A and strike any key. Maybe this disk is bad. Maybe that diagnostic process messed it up or something. I'm gonna just image a new one onto here. All right, fresh copy of IBM DOS 3.3, and I was wondering, the computer was just sitting there and it rebooted itself, which is odd. Pop that in. Let's see if this thing boots. It does not. What is going on with this computer? I tried 2 different controller cards, neither work. I don't trust that this BIOS is reliable. I need to find a fresh, better one to put on here because this one seems crap. I'm gonna use the OpenSOC SOC86. It's an open source reverse engineered XT BIOS, and they have a distribution that has 2764 chips. That means that's the same as the original BIOS on here, and there are 5, although 1 is the BIOS and there are 4 for basic. And I'm gonna burn those onto some chips and see if this works better than this junky BIOS. EPROM is flashed, it's installed in the motherboard. Switch over to the right input. Nothing is plugged in backwards. Hey, look at that, it's even has a blue bar at the top, fancy. System has V20, no FPU. It doesn't have a V20. Oh, it's still not working. It does exactly the same thing. So obviously something's the matter with this board beyond this. It does have a V20 CPU, by the way. Looking down there, yeah, that's a V20. It's not working. Interesting, interesting, interesting. Why would it start to boot and then fail? Other than maybe there's something wrong with like the interrupt controller, because I know the floppy drive needs that. Control delete again. Is there any menu or anything? I don't think there is here. It thinks it has a game port? Game port? That's weird. Let's take this controller out of here. There's no game port. No ROM basic booting from disk. Well, there's no disk, so that's not gonna work. I tested the very abused XT IDE in another computer, And it turns out that putting it in backwards did nothing other than damage the EEPROM. So I put a new one on here and it has the correct settings for this card. And this card should be working again in this machine. So let's pop it in. I switched over to the small LCD and the RGB HDMI is still hooked up. Let's power this up. All right, game port again. It's back to that. Weird. There's no floppy controller currently in the machine. Booting from hard disk. Okay, good sign. Hey, look at this. Oh, it's working. It's actually booting the system. So let's try check it here, see what we see. All right, all pretty standard stuff. So this machine is actually functional. Very interesting. Huh. Look at the BIOS date, 2012. That's because I'm still running that open source BIOS. All right, well, this is supposed to be a turbo motherboard. Let's check it out. Oh, look, 4.77 megahertz. So it's definitely not very turbo. The performance bump you see here is because this has a V20 processor in it as opposed to the standard Intel affair. So one thing is I thought this was a laser turbo XT motherboard, but I went to the manual for that machine and definitely this is not the same motherboard as in that machine. Like the RAM is over on the other side and there's extra chips here. So clearly this is something else actually in here. And maybe the floppy drive not working is because I have the dip switches wrong, although you would think that they would just copy the XT dip switches anyways. So for sure, back in the original video when I tested this machine, I was getting the error number 4 on it, which I've crossed out. And I wrote XT Turbo no floppy boot. So, okay, why don't I stick back the original BIOS on here? Let's give that a try. Out with that chip, in with the PC Turbo 89 chip. All right, here we go. What's gonna happen? Okay, it's working at least. Is it gonna give us an error? Is it gonna boot? What's it gonna do? I mean, there's not even a floppy drive in this machine, so maybe the way the jumpers are set up right now, so maybe the dip switches are currently set for no floppy drive. It just says floppy drive A present. And look up here, original HP Vectra? Really? I started doing some Googling for PC Turbo. That didn't find anything. And then right here it says copyright by Bison. And it might be a little hard to see, but it says Bit Plus right there. Doing some searching for Bit Plus XT16-2, which is written right here on the motherboard. That results in nothing. According to Wikipedia, the HP Vectra was released with an 8088. So I wonder if the BIOS on this board is some kind of a clone of the one on the Vectra. Unfortunately, I'm just doing some searching to see if I can find the manual for the original Vectra, but it's impossible because there were so many versions of that machine over the years that you get results for everything else besides that very first 8088 version. The reason why I was looking it up is because this machine is supposed to be turbo, so there should be a way to make this thing run faster than 4.77 megahertz, and I can't quite figure that out. I've been looking all around on this board for a possible jumper that might be like the turbo speed, and the only thing I can find is there's actually a jumper back here, but if I short that, it just reboots the machine. It's a reset button. I'm also not seeing any additional crystal oscillators on this thing that might yield multiple speeds. I'm really not sure this is going to be in focus, but up at the top of the board there, it looks like there's room for another crystal oscillator and a few ICs, and they're not populated. So perhaps this machine is missing the turbo option, and maybe that BIOS is actually not even from this computer and someone else put it in there at a later date. Looking at the date codes on the ICs on this board, they all seem to be from around 1986. So this 89 on the turbo BIOS here doesn't seem to coincide with the original chips, at least when this board was made. I'm running top bench because it's good because it's a real-time benchmark, and it's saying that the machine is about the same speed as a PC Junior with a V20, which makes sense. 4.77 megahertz, we're getting a score of 5, so slightly under the PC Junior. I have this XT keyboard down here, and on some machines, like on the actual Laser XT, you push Control and 8 and 5 for the different speeds. 5 is for 4.77 megahertz, and 8 is for turbo. Now, that doesn't do anything at all on this machine at all, and I've tried various combos like Control, Shift 5, 8, 4, all the different numbers, nothing. I've also tried using the plus and minus on the number pad. That was another way that some machines went to turbo. So like Control plus, Control minus, Control Alt Shift. I tried every combination. Nothing seems to make this computer run any faster than 4.77 megahertz.
If you're watching this and you can use your search engine skills better than I can to figure out what's the deal with this motherboard and maybe how we can make this thing run faster, definitely put a comment down below. I'd be very curious about that. But at this point, I guess I'm just gonna assume that this is not actually a turbo motherboard and it's just one that runs at the stock XT clock speed. Kind of boring. And we are still left with the fact that the floppy drive didn't seem to work. So I'm gonna go back to using this floppy controller here. Let's see if we can get the disk drive at least reading a disk. At least now we can boot to DOS. Perhaps I can read it in DOS, even if this thing can't boot. All right, so pop the disk in here. It didn't even attempt to seek or anything. That's very sketchy, but it feels like that's just a problem with the jumpers. Okay, A drive. It is trying to read it, but what are these weird control C's that just popped up? I know you aren't gonna be able to see that on the camera. What's going on here? The drive is spinning. Very strange. You know, this has me thinking, maybe there's a problem with the interrupt controller or the DMA controller on this. I think both of those are required for the floppy drive to work. And I know XT-ID does not require an interrupt or DMA. I don't think the CGA card uses either of those either. IMD is a good program to use for testing the disk drive because this bypasses the BIOS routines and talks to the disk controller directly. So let's see what happens here. That's working. It's reading the disk. I'll turn the sound off. So that's reading the disk perfectly. Let's switch to another track. Yeah, we're still getting 18. That's exactly what it should be. Okay, so I'm very confused. Controller's working, disk drive is working, the disk is working, and yet when we try to access the disk drive in DOS, it actually fails. Let's try dir a: now. Okay, wait a second. This disk might actually be blank. Let's try to copy a file onto it. No, that did not work. All right, it's time to pull out the big guns. This is the Kickstart IRQ card, and I haven't shown this on the channel before. This was a donation locally here in Portland. I think what this basically is a very fancy postcard. So it shows you postcodes on machines that have it, but it also shows you all IRQ and DMA activity as well across the bus. So as soon as one of those is triggered, you will actually get a light that stays on here just to help you understand what signals are on the ISA bus. I have only limited experience using this card, so let's see what happens when I turn the power on. Okay, IRQ6, DMA2, which I am pretty sure both of these are used by the floppy controller. I think this button right here will reset them, yep. All right, I rebooted the computer and it just says IRQ6, there's no DMA channel. I'm gonna run IMD. I've just run IMD and I'm gonna clear out all of the status LEDs and I'm gonna try to access the disk drive through IMD here. Okay, so it definitely is using the IRQ and the DMA. And yes, it's reading the disk without a problem here. Let's just reset those. See if they come back on when I change the track. Yeah, as soon as I change the track, they come right back on. And I did just double check against the IBM dip switch settings and 7 and 8 should be on for one drive and they are. So I just don't really get what is going on. I'm thinking that this BIOS maybe is somehow incompatible or it wants a specific floppy controller. None of it really makes sense to me. I'm gonna reset this and now I'm back in DOS here. Let's dir a: Okay, the lights came on. It does say file not found, but I have to say, I think that disk has DOS on it and is not seeing it. And I am 100% positive that this disk controller works perfectly, as does this floppy drive. I've tested these both recently in another machine, no issues whatsoever. Why don't I go back to that other aftermarket BIOS chip, because maybe it, well, I mean, it wasn't booting either, but let's see what happens when we try to access the drive in DOS. All right, there's a boot ROM on here too. It says landmark research, D for diagnostics, C for continue. I tried hitting D, it didn't do anything. I have a feeling that is looking for AT scan codes, not XT scan codes. All right, once again, it didn't even attempt to access the DMA channel, but it did access IRQ6, which is the floppy controller. dir a: No. Okay, look at this. I just typed dir a: enter. I don't know what this control C is, and now the text is purple as well, and the floppy drive is just spinning. Something is still weird on this board. If we look at the board here, the CPU is up here, and there's gonna be, I think, a clock controller sort of back there. You can't see it because the card is covering it. But then there are these ICs as well that are part of the chipset. This is the keyboard BIOS, almost certainly. This NEC chip is an 8237. That is the DMA controller for the XT. This here is the 71054, which is gonna be like a timer chip. And then this IC is the NEC D71059 Charlie, or C. That is the interrupt controller for this motherboard. So because it seems to not matter which BIOS chip I have on here, and the problems with the floppy drive are the same, I almost feel like it's either the DMA controller or the interrupt controller that is causing the problem. But I'm wildly guessing here because I just don't have a lot of experience troubleshooting these exact board level problems on XT architecture. And I did just check what spares I have, and a viewer sent these in a little while back. 8237A, that is this IC here, which I think is the DMA controller, or is it the interrupt controller? Yeah, that's the DMA controller, I think. And there are interrupt controllers on here as well. 8253, no, that's not right. Which one is it? 8259. That's this IC here. I think that was the interrupt controller. I already forgot which was which. But anyways, I have the ICs here. I also have this IC, which I guess is not the keyboard BIOS. That's the 8255, which is, oh, I just saw it, is this one right here. So I was thinking I was gonna end this video here, just asking for advice on maybe what I should do with this motherboard. But I have decided to replace the interrupt controller and the DMA controller. Well, at least socket both of these ICs, and then I can try out these spares I have. I have one of each. It'll be an interesting experiment. One other thing to consider is I was reviewing old footage of the machine that I took this motherboard out of, and there was a multi-IO RAM card in here with a battery that leaked. And one of these slots, I forgot which one, was all corroded, and there was corrosion on the motherboard as well. So this might actually just have a fault where a trace is broken or something like that as well. I'm still gonna go ahead and socket these chips, but if that doesn't seem to change anything, or if I put these in and that doesn't change anything, I may have to spend some more time trying to figure out a broken trace. There was another tidbit in the footage from the machine this came out of. There was a hard drive controller card in here with a working hard drive, and when you tried to boot off that hard drive in this motherboard, it would freeze, very similarly to the way the floppy drive is not working, just would act unpredictable. I brushed that off in the original video as the hard drive just not working, but eventually I took that controller and the hard drive out of that case and I booted it successfully and perfectly on another machine. So I'm gonna start trying to socket this. We'll see if that makes a difference. All right, one interrupt controller removed from the board. I'm gonna install this socket right here. There we go. Just pops right into the board. No fuss, no muss. All right, one socket installed. Why don't I put this new chip back in? This is an Intel variant of the interrupt controller, 8259A. This is the 71059C, but I looked up the NEC data sheet and it's definitely the same as this Intel one here. It's just, I think the difference with the NEC one is it supports faster clock speeds. Since we kind of determined, well, I think we kind of determined this motherboard is not a turbo motherboard, there's just seemingly no reason to put a turbo fast one in here. I mean, unless there's something I'm missing, that this board is faster than the 4.77 megahertz that it seems to run at. But this Intel chip I'm putting on here, this is one of the original ones, and it is definitely not good for more than 5 megahertz. All right, chip is installed. Looks like it's in there properly. Let's power it up. Okay, we're set up. VGA is connected. Let's power this up. I think this is my boot disk. I should verify that this is actually a boot disk. First, let's see if it gives me an error about like no, I don't know, boot disk or whatever. No boot ROM, booting from disk. Okay, fair enough. Okay, the light is on and nothing is happening. Okay, insert boot disk. We had that error before though, so that is not indicative of anything. What's happening here? It's spinning. Okay, I am not thinking that there is any improvement on this machine. And definitely this is the original NEC interrupt controller, and this is the Intel one that's in here. It's a little bit warm, so it's powered up, but doesn't seem to be working. Well, we know an easy solution is switch to the XT IDE here, let this thing boot up, and then not plug it in backwards either, plug it in the right way around. Okay, there it is. Power up this little card here. This thing does need power. I just used one of my other computers to image a fresh copy of DOS 3.3 onto here, so I know it's a good disk now. And A colon, no, right away, getting those control C's. I know it's not super clear on the camera, but that is exactly the same problem. There is no improvement whatsoever. Now I want to try something now that this is socketed. Let's take this chip out of here and see if this computer works at all without this. Now, the keyboard, I'm pretty sure, uses an interrupt as well. So without the interrupt controller, I don't think we're gonna get any activity on the keyboard either. But I'm curious to see what a PC does without that chip installed. Let's see. Good thing is the original chip here, I didn't damage it in any way, so I can just put this back in the machine. So the machine locks up and doesn't actually boot at all. Does the keyboard even work? Let's just see. I'm about to put the original one back in here. Curious about the keyboard. No, we have no keyboard control. I know you can't see it, but I'm pushing Control-Delete and nothing is happening. The keyboard is, well, definitely plugged in. Okay, so your keyboard doesn't work if you don't have your interrupt controller in the motherboard. Let's put the NEC one back in. See if I can use the keyboard now. Yes, that rebooted the computer. So definitely without interrupts. Oh, how weird. That actually stopped the memory check, but the computer is definitely booted now. DIRA. Okay, well, it froze. It didn't put the control C's, but it still froze. All right, I had a thought. What I haven't done is take the CPU out of the socket here. What if the CPU is slightly acting up? I mean, no, I don't think it's the CPU. I just popped this original NEC V20 out of here. Fortunately, a couple pins got bent because the socket was extremely tight on the chip. I'm gonna just stick in an Intel chip in here. Let's just try another one. What if this has a slight fault? I don't really see, I mean, I'm really grasping at straws here. This is terrible troubleshooting. Absolutely terrible troubleshooting. But sometimes when you don't have schematics and I honestly don't really have an idea of what might be causing the floppy stuff not to work, you gotta kind of grasp at straws a little bit. And it wasn't that much work to swap this chip out, and of course swapping the CPU. It's already socketed. That's super easy. And I will just pop in this original 8088 here. It's from 1981. Well, at least that's the copyright date on it, made in the Philippines. And then we have absolutely no change. Not the CPU. So I said something a moment ago which should have been a thought earlier in this process, in that the keyboard does not work without the interrupt controller. Well, I'm touching the ROM, but here's the interrupt controller. The keyboard is IRQ2, I think. Real-time clock, oh, well, that's not on here. But yeah, the keyboard definitely needs an interrupt. So we kind of know the interrupt controller is working because the keyboard has no issues whatsoever. And that kind of goes back to the other thing that the floppy controller uses and the hard drive controller is the DMA channel. Now, not all hard drive controllers use DMA, but I don't really remember what was in here. It was some kind of an XT one with a ROM BIOS. Could have easily used DMA. Although, I don't know. I am grasping. I'm still grasping. Believe me, I'm still totally grasping. So I'm gonna remove the interrupt controller and socket that so we can just double check that it's not that chip. And through the magic of editing, there's that socket installed on the board. It was a very easy, painless removal. Well, I should just use a little IPA to get this Sharpie off the back of the board. That'll come right off. But there it is. What I want to try now is what happens if I run this without the DMA controller. Do you get an operational PC, one that can at least boot up into DOS using the XT IDE, for instance? What's sort of funny is I've done so much work over the years on PCs, but I haven't ever done experiments like this because I haven't had socketed devices. Okay, The computer's not even posting at all without the DMA controller installed. So it seems to be a very critical part of the system. I'm going to install this Intel IC here. Just straighten out a leg before it goes in the socket. Let's just see if the Intel chip is working. I mean, it's actually good because I can test these. These chips were untested up until this point. Okay, that went in really easily. Let me just double check the pins are good. Yes, they are. It is correctly oriented in the socket. 8237A, 8237AC. So definitely the same part, except that's Intel and this one's NEC. What happens now? Hey, the VGA monitor's coming on, so it's posting. Okay. I do not have the floppy drive connected. It is sitting down here on the floor. Not a good test. All right, it's connected now. Here we go again. Time for another boot test. Take the disk out here. Let's go to DOS. This is terrible troubleshooting. And I know I've said that already, but it really is bad. This is known as, in the car industry, the parts cannon. When you have an error code that you're not quite sure what's causing it, you just throw parts at it. All right, so the system is booting. That's a good sign. No, it's still dead. Yep, so, right. And it totally freezes. Oh, actually, it didn't totally freeze. Sometimes it totally freezes a computer. All right, so we know a few things. It is not the CPU. Okay, first of all, it doesn't even try to boot off the disk when you have XT IDE in there. You gotta push the A key, like I just did there. So we know a few things. CPU is good. Interrupt controller is good. DMA controller is good. Yet, the floppy drive doesn't work, and possibly the hard drive. If anyone has any suggestions on what might be the problem on this motherboard, besides the interrupt, CPU, or DMA controller, please let me know. I'd be very curious to see, but it certainly works fine off the XT IDE. It just fails anytime you try to use the floppy drive. I mean, what a strange mystery to me. I suppose the one thing, and I'm thinking out loud here, that I didn't check is that the interrupt request line for the floppy drive, whatever that is, I didn't check that it has continuity through to the interrupt controller, because maybe that line got damaged due to the battery leakage. By the way, the slot doesn't matter. I can plug the floppy controller into any slot, it doesn't work. So anyhow, I think I really need to end this rambling video here. Terrible, terrible video. So suggestions welcomed. If you liked it, thumbs up. If you didn't, hit that thumbs down button. I can't see a count of thumbs downs anymore because the YouTube changes, but you could still hit the thumbs down button and it tells YouTube backend system that you don't like it. I just don't know. And yeah, hit subscribe if you haven't already. And thanks to my patrons. I really appreciate their support. If you want to become a patron, you can do so at the link in the description. And that is going to be it. Stay healthy, stay safe. I'll see you next time. Bye.